So, good morning everybody. Now, I will start the introductory level of this course, Advances in Welding and Joining Technologies. So, to some extent we know about the different welding techniques, and we have seen in the several places that materials are joining simply gas welding processes or some other welding processes. But if we look into the science behind this welding and joining technologies, and then we can find out that most of the subjects are involved in welding and joining technologies. For example, here we will be able to know that heat transfer analysis, the involvement in welding processes, material flow and any kind of stress analysis, distortion level and metallurgical changes, that means structural changes, microstructure, that means material science, metallurgical engineering as well as mechanical, manufacturing, some design, and all are basically involved in this in the welding processes. So, we will try to get some idea, some basic idea about this process. So, that we will try to cover the welding science and what are the technological development of this process till date, that we will try to cover in this module. So, the module consists of this following sections. Maybe you can say that first is the classification of the welding processes, then what are the physics of welding processes, and then mostly use the fusion welding processes, their development and different types of the welding processes. What are the bridging and soldering processes? Soldering processes in regular life we can see that to mainly we can use on some electrical circuit board. There is typical application of the soldering processes, but bridging also in industrial scale application also there, but we will try to look into that what is the typical mechanism of bridging and soldering processes. Then adhesive bonding is one kind of the joining processes. We will try to cover these topics also. Physics of welding arc, because so far much development has been done in the arc welding processes. So, we will try to get some idea about the physics involved the formation of the arc and in very specific to the welding processes. Then more advanced topics in this section, that is what is the influence of the surface active elements, and based on that what are the different welding processes has been developed, or maybe existing welding process, what way we can modify these welding processes by considering the effect of the surface active elements. And finally, we will try to cover the magnetically impelled arc welding process. So, these are the module of this different section of this module, and that name of this module has been given in such that way that fundamentals of welding and joining. We will try to get some idea, basic physics involved in the welding processes or most conventional welding processes, the different technology of the welding processes. We will just to get some broad idea about the processes. If we see that almost all sector of the industry, there is a need of joining of the materials, that can be done either fusing of the metals or maybe using some adhesives or some other joining techniques. If we see, listed some of the applications area. So, electrification, automobile, airplane, water supply and distribution, electronics, radio and television, agricultural sector, computer, telephone, air conditioning, and of course, almost all sector it is covering this thing. So, it is indeed is very much important to know about the fundamentals of the different welding processes. Now, if you see the mostly use this technology in the airplane or aerospace industry, highway, and the health technologies, spacecraft, and the recently the different welding processes has been developed looking into the application of the high performance materials. So, it covers almost all the sector. So, here the importance of the welding processes, and before going into details, much details about all the welding processes, we will try to get some basic mechanism of all this process. Probably it can be a review of the different welding processes, their mechanisms are only will be focusing in this part. And now, how we can define that what is the welding and joining. So, there is no precision definition of welding processes or joining processes, rather we can say that when two metals, specifically metallic materials, are joined by fusing with the application of different type of the heat source. So, that in general that is called the welding processes. Normally welding with involvement, there is a fusion is there, and joining processes maybe in other way, that for example, that when you use some fasteners, mechanical riveting, and use the fastener to joining the two components, that is also termed as the joining processes, but there is no need of any kind of fusion or maybe atom to atom covalences is not required in that cases. So, that can be considered as a joining process. For example, even in adhesive bonding also, if you use some glue and to join two materials, that can be also called a joining process, but here the mechanism of joining process is different from the fusion processes. So, that fusion is happening in the welding and joining processes, specifically that is termed as the fusion welding process. Of course, we can say that solid state welding processes also can be considered. We generally say solid state welding process, sometimes also we can say it is a solid state joining processes. Even the soldering and brazing, that is also the application of the third metal, try to join the two different material by fusing the third metal, but not necessary to melt the parent metal. So, that is the basic mechanism of the soldering and brazing mechanism. So, that also we can say one typical joining mechanism. So, in general we can say that it is a not only welding or not only joining process, we can say it is a welding and joining processes of the materials, irrespective of metals or irrespective of any non-metals also. Now, critical technologies in manufacturing, mainly recent or maybe huge application, or I can say the maximum application of welding and joining technologies we observe in the construction industry and as well as the mining industry, and specifically in this case the joining or welding of the materials involves there is a huge large amount or maybe thickness, or the thickness of the metal is very high in this case. But at the same time, if we find out the very precision application of the welding and joining technologies that we observe in the health technologies, biomedical devices, there we can find out the requirement of the joining of the very small thickness, maybe less, sometimes it is requirement is maybe less than 100 micrometer. So, we say that as such the application of the welding and joining observed from the very precision instrument in the level of 100 micrometer or less than that to a large extent that we observe in the huge thickness or the bulk joining of the material, we can find out in the construction and the construction, specifically if you try to make a bridge, there also apart from the rivet joint, the welded joint can also be done for the construction industry. Specifically the example is the making the bridge, the river bridge, and then another cases is that mining industry also we can find out there is a huge application of the large scale welding processes. So, apart from very large scale to very small scale, there is importance of the different welding and joining technologies. So, now here we will try to focus in general of the welding technologies, and there is a separate module of the micro joining and nano joining section, where we will try to focus on the very precision welding processes in very small scale. But why it is important, the welding and joining analysis of all this welding and joining? Because from the past it has been observed that if the technologies of welding and joining are not proper probably we can find out there is a formation of the defects, and presence of the defects may lead to the catastrophic failure of the whole structure, and that can lead to the loss of property as well as the human life. So, here is the important to analyze the different welding processes, and if there is a formation of the defects, or whether we can choose the different welding technologies for without any defects. So, this is not only the problem in the welding industry, the formation of the defects by the improper choice of the welding materials or improper selection of the materials, in the sense that with respect to the material, if welding process is not proper, then there may be the problem of the formation of the welding defects. Not only this, finally, if we use any kind of welding processes, whether it is solid state welding processes or fusion welding processes, we can find out that there may be the formation of the some amount of the residual stress and distortion that can be controlled, but that cannot be completely avoided. So, presence of residual stress also affect the life of the welded joint. So, always we try to target to reduce the nature of distortion and nature of the residual stress. So, that is also another problem, or maybe I can say that that is the that comes by inheritance, that presence of the any kind of residual stress and defects during the welding processes. So, in that sense, it is also necessary to analyze the or to know the basic mechanism or basic engineering of the different welding processes. Now, before that, welding and joining processes can be classified in the following way, that based on the different types of welding. Of course, the classification can be done from the different perspectives. So, with respect to that one perspective, you can say that there are three different, one is the fusion welding, pressure welding and friction welding. So, here basically the difference is that nature of the heat source and how we can control the heat source, or how heat can be generated to join two different or similar kind of materials. Fusion welding, definitely we apply the source of heat source in such a way that it should cross the melting point of the substrate material, so that it can fuse together, and after solidification it makes the structure. Pressure welding, simply application of the pressure or maybe application of the load is the main mechanism to do the joining of the materials. Friction welding, of course, the heat is generated in this case due to the friction. So, in friction welding, normally we generally keep the friction welding, the maximum temperature is below the melting point temperature. So, in that case they can be considered as a solid state welding process as well. So, these three types of welding processes, and we can see further that fusion welding processes can be classified as the homogeneous and heterogeneous welding processes. And if we see other part is the heterogeneous welding processes, that bridging and soldering. The heterogeneous welding processes means that we use the some another second or third material to join the similar kind of material or two different type of material. So, in that sense it is called the heterogeneous welding processes, and in the other case the homogeneous welding processes, here we can find out that may not be necessary to using the third material, maybe two similar kind of material they can join, it's a and can form kind of homogeneous structure. Even for dissimilar materials also they can join together, but finally they can form the homogeneous structure. So, in that sense it is called the homogeneous and the heterogeneous joining processes. So, homogeneous, there are several types of welding processes. We can see that gas welding process, electroslag welding process, high beam energy and the electric arc. So, all these cases the generation of the heat mechanism are in all these cases are different, but common thing is that anyhow that when you try to join two materials, maybe there must be some amount of the heat generation should be there, so that the materials can be joined together. So, but all these cases the source of the heat are different. First case is the gas welding, simply burning the gas is the amount that actually converted the basically chemical energy and the converted to the heat energy, and that heat energy utilized to weld the materials. Then electroslag welding also similar kind of, maybe in this case that arc can be generated, then high beam energy also, that beam means the either laser or electron beam, that is a high source of energy can be used, and electric arc based on the electric arc can also be used in this case. So, all these different types of the homogeneous welding processes, but in this case the heterogeneous welding processes mechanism are different from the homogeneous welding processes. So, heterogeneous processing process we generally we conventionally can find out the two different types of welding process, one is the brazing and another is the soldering. So, in details we will discuss about all these processes. Now, other things we can see that electric arc welding, there are three different types of MIG welding, metal inert gas welding or gas metal arc welding, then TIG welding, tungsten inert gas welding or gas tungsten arc welding, and shielded metal arc. Shielded metal arc welding also, that is sometimes it is called the stick welding, that most of the cases we observe that shielded metal arc welding process, and we practically we can observe and in any kind of construction site that using of the these different types of the welding processes. So, that can be that are categorized as the electric arc welding, because in this all these cases they produce the electric arc. So, in general that generic types can be classified of the welding and joining processes, or rather I can say that what are the, maybe you can say that rather than classification, here we can say what are the different types of welding processes here. So, in this case fusion welding process, we see the arc, gas, power beam and resistance, that actually can be categorized as a fusion welding processes. Thermomechanical processes can be considered as a friction, flash, explosive welding process. So, in this case the not only the thermal condition, maybe some mechanical energy also required in this case, and in general that is called the thermomechanical energy utilized for all these cases, and fusion welding only heat energy or maybe thermal energy is utilized to conduct all these type of welding processes. Then mechanical joining processes. So, it is not the welding, but it is a joining process, because fasteners can be used simply joining up the two components. So, that is called the mechanical joining process, or maybe in general that is the joining processes. And solid state welding process, another generic type of welding and joining process, that is called solid state, that is adhesive, soldering and brazing can be categorized as in these terms, because in this case the temperature actually below the melting point temperature of the substrate material. So, in that sense it is called the solid state welding process. Even for friction state welding process, that is there also the mechanical stirring action as well as frictional heat generation are responsible for the welding of the material. So, that can also be categorized as the in that solid state welding process. So, point is that when you try to classify the different welding process, so we need to consider the different perspective to classify the different welding process. So, these are the one way the different types of welding process normally exist. If we see in other perspective, what we can classify the welding process. So, before that we look into that what are different types of welds we generally observe. If you first figure, if you see that there are three types of welds. The first one is the two common application are for the hard surfacing, basically surface welding, means that means it is application of the heat and making the joining of covalences of the materials is happening only over the surface. Second one is the groove welding, making a groove between the two plate, and that can be that groove is filled using some filler material. So, the primary use of the groove welds is to be complete the bar joint. So, configuration of the bar joint, because In this case, two plates are flat and they are joined at the edge, and either using any filler material or not. So, that can be that also one type of joint, that is in general that is called the butt joint, but also can be considered as a group joint if we try to make some group before the welding of these two metals. So, another types of weld, that is also fillet weld. So, fillet weld, the configuration of the geometry or of the base metal are different in this case. If you see, although it is making the kind of T section, but one sided it is wound or filled by the welding material. So, that is called the fillet weld. So, have a triangular cross section used and that are at 90 degree angle. So, fillet weld, it can be done over a T cross section, and the lap joint, two different metals joint, and then that can be welded using the materials, or it can edge joints, or it can be two edges having 90 degree perpendicular, they can be joined using the fillet. So, these are the type of welds, different welds, but type of the joints can be other way. We can observe that butt joint, simply joining of the two materials over the edge, and then lap joint, when the lapping over lap joint, the one plate is in over the another plate, and any one of the contact can be joined using the filler material. So, that is called, or without using the filler material, that is called the lap joint. So, here the geometric configuration of the joint are different in this case. Here if you see the T joint means that one plate is horizontal plate is there, and over which 190 degree over vertical plate are kept, and then both side can be joined or single side can be joined. That is called the T type of joint. Corner joint. So, the two plate are keeping perpendicular with each other, and that corner are joined using the welding processes. And edge joint. So, over on the edge the geometric configuration different, but over the edge the weld can be done. So, from the figure it is obvious that there are different types of welds, and there are different types of the joints we can observe practically by what way we can configure the different materials, we can say different substrate materials. In that way we can find out this is the different nature of the types or nature of the weld joints we observe in practically. Now, again we come back to that classification of the welding and the joining processes. Maybe other way we can, in general we can say that joining processes. So, joining processes itself include the welding processes also. So, in the joining processes we can see there are two different, one is the permanent joint, another is the non-permanent joint, and another is the semi-permanent joint. So, from that way we can categorize the different joining processes. First is the permanent joint, maybe welded joint can be considered as a permanent joint, and because coalescence of the materials happen in this case, it may happen either in the liquid state, that means cross the melting point is above the melting point temperature, or it can happen in solid state as well also. So, both can be considered as a permanent joint. Second is the soldering, and here also soldering is when soldering is done, joining between the two components, the solder material needs to melt and it can join the two materials, but not necessary to melt the parent metal. So, this also creates some permanent joint. So, similar philosophy also for brazing also, and this also called the permanent joint. And of course, rivet joint, this one kind of I can say the mechanical joint also, but this is also this can be considered as a permanent joint, but non-permanent joint in the sense that bolted joint and screw joint, because it is possible whenever required it is possible to disassemble of the joining materials. So, in that sense it is considered as a non-permanent joint, but in other way when rivet joint can be considered as a permanent joint in the sense that if you want to disassemble the components, then it needs to break the other rivet part. That is why it is considered as a permanent joint, but it is not necessary for the bolted joint or the screw joint. Semi-permanent joint can be categorized as the adhesive bonding, because adhesive bonding, when you joining two materials, we put the adhesive between these two materials, and after curing of the after certain curing time, the two components or two metals can be joined. So, that is the joint by using the adhesive bonding, but this adhesive bonding having some life, after certain time they can be disassembled, but that depends on the what type of adhesives we are using. So, in general this adhesive bonding can be considered as a semi permanent joint. So, in that prospect, or the different permanent, non permanent or the semi permanent joint. So, this is the one way of the classifying the different weld joining processes. So, if we look into other way, the welded joints, so that is the classification of the welded joint. So, several joining processes, that fusion welding, then metal deposition process and pressure welding. These three main categorization can be done when you try to classify it of the weld joint. So, if you look into that, what are the different types of the welding process includes in the fusion welding process, that gas welding, arc welding, high beam energy welding and thermite welding. So, all these cases we apply the heat source intensity in such a way that it try to melt the basic material or base material, and then after solidification the permanent joint can be done. So, in this case, so here nature of the heat source is applied in such a way that it will try to fuse the base material. So, that is why it is comes under the category of the fusion welding. So, that fusion welding, the source of the energy here in the by creating the arc or chemical in the using the gas or using the high beam energy like laser and electron beam. But in case of metal deposition process, the sense of the classification is different. In this case, of course, we use the source of the energy, different energy is it try to fuse the material which solder material, but it does not fuse the base material. So, that is why the metal deposition process, in the sense that we use the another extra material to join between the two metals without reaching the melting point of these two materials. So, soldering, brazing and adhesive bonding also comes into under this category. So, that means we use some extra material to join between the two components without melting the parent components. Pressure welding, other categorization is that here you can see that what are the different welding processes includes in the pressure welding process, that friction welding, ultrasonic welding, explosive welding, diffusion welding, resistance welding and magnetic impelled arc welding. So, in this case normally the pressure welding means the application of the load is required. So, that actually try to create the joint or bonding between the two components two materials. So, friction welding, of course, apart from the pressure, some frictional heat also generated in this case, that actually helps to covalences of the components of materials. Similarly, ultrasonic energy can be used in this case to joining. Explosive, when the using some explosive in this case the using some explosive and then highly deform the components is highly deformed, the high rate of plastic deformation will happen within the component, and then these two components can join in a solid state, create some solid state welding processes also. Similarly, resistance welding also, resistance welding in this case that we apply that resistive heat also, but at the same time to make the joining process we need to apply some mechanical load as well. So, in that sense the resistance welding of resistance, the it creates the due to the ohmic heating, it creates the generates the heat, but at the same time we need to apply some constant pressure or maybe some variable pressure also, so that the welded can be done. So, apart from the various kind of the source of the heat or generation of the heat, there is also some mechanical loading condition is also required in case of the pressure welding. Anyway, we will try to discuss of all the different types of the welding processes as well individually. So, By looking into that different way of classification of the welding processes, now we will try to focus on the that physics of the welding process. So, how the joining of the two materials comes and what way the different development of the in the welding industry has been done over the time. So, first question is that if it is possible to bring two metallic surfaces together, is it possible to join these two surfaces or two components? If that is possible, then I think there may not be necessary that such kind of all this development in the welding processes, but let us look into that things. Since the only grain boundary separate them, that means between the two metals, if that in that case two metals come in contact with the metallic surface come in contact, then joining adherence with the large force is possible, but this is the very ideal case, because that type of metallic surface may not be possible in practically, because that metallic surface most of the cases we can find out they are contaminated with the oxide layers. So, ideally it is not possible to bring the two metallic surface if it is not contaminated with any kind of layer of the metals. So, in that sense, in absence of that layer, that two metallic surface come into the contact, then it is possible to join between these two metals. But apart from this, if there is any presence of the oxide layers, then in that ideal cases it is possible to join, but practical cases most of the metallic surface accustomed with some of the oxide layer, and it is not possible to join them until and unless there is a removal of the oxide layer. So, that presence of that oxide layers is basically brings the concept of the different development of the different welding processes by the mainly by the application of the amount of the or the some kind of creation of the generated heat between the surfaces. So, that actual practical that surfaces presence that deals with the phenomena associated with the different welding processes and development of the different welding processes. Now, the formation of the weld bead bonds, basically that fusion welds or even solid state welding commonly differentiated by the physics of the metallic bonding mechanism. So, that is the only difference the in weld bond, or that is the only metallic bonding, the nature of the metallic bonding, what way it try to explain the fused or solid state welding processes, either in the fused welding processes or in the solid state weld. So, we will try to look into that deviation from the ideal cases and what are the development of the welding processes can be done. Now, before that we will look into that what is the physics principle of the fusion welding processes. So, in fusion welding processes basically they are created by the covalences of the molten base metals and mixed with the molten filler metals, but not necessarily always the filler metals are required. So, in this case the fusion welding happens by the way the metals must be heated to raise the melting point temperature for fusion weld to be produced. So, in this case what happens, raised to the molten temperature and they mix up, the molten metal mix up, and then finally they solidify to the ambient temperature and then actually makes the bonding between the two materials. So, that bonding may happen either similar type of materials or maybe two different types of the materials, but in this case the typically the fusion welding process it is characterized by the molten pooled zone, basically the molten zone and then heat affected zone. So, heat affected zone also occurs because the heat is applied to melt the surface, but up to certain extent there may occur the phase transition or phase transformation happens, and that is inherent to the processes. So, that phase transformation measure the phase transformation effect is basically indicated by the heat affected zone, and that heat affected zone is basically identified the microscopically or macroscopically as well. What after solidification or maybe after cooling down of the molten pool, and then when it cools down to the room temperature, then there may be the possibility of, definitely there must be some amount of the distortion and residual stress, and over the solidification period some metallurgical changes also happen. So, like the phase transformation also happens in this way. So, that metallurgical transformation, all this this can be better identified by the different size of the molten zone or different size of the weld zone or different size of the heat affected zone. So, in this case what we understand that in fusion welding process there is a necessary to apply some intense heat to the focused zone. So, that intense heat basically melts the selective part of the material where we are about to join between the two components, and after melting it subsequently solidify and creates some different metallurgical zones, maybe that is called the fusion zone or heat affected zone, and of course, remaining part is the unaffected, the base metal. So, these are the typical characteristics, but other way also after solidified of the molten zone it is accustomed to some amount of the distortion and residual stress. So, this is the principle of the fusion welding processes. Now, what is the solid state welding process? So, solid state welding process, definitely the temperature should be below the melting point temperature, and arc created by either the macroscopic or the this is the basically created either the macroscopic or the microscopic coalescences of the materials, and that remains in the solid state. Of course, phase transformation may also happen in the solid state, but that phase transformation is the happens below the melting point temperature of the materials. So, apart from this, the fusion welding and that principle of the fusion welding we discussed, and that principle of the solid state welding process. Now, we come to that point, the physics of the arc welding process, in the sense that when you try to because arc welding is the mostly used process and most common processes also, and in arc welding process we generally control the several parameters. First is the voltage. So, electrical potential or the pressure that causes the current to flow, that voltage is that potential that is required to flow the current, and basically the current can be defined as the movement of the charged particles in a specified direction. So, voltage decides the flow of the current, and current actually is basically in terms of the charged particle, and that flow one direction, and then that when there is a current flowing in specified direction, and when it creates the arc between the positive and negative charge workpiece and the electrode material, and then it try to complete the electrical circuit. So, that electrical circuit makes the development of the arc welding process, but in this case this electrical circuit or nature of the voltage and current is basically different from the other common electricity what we use in the this thing, that normal in current, that means for specifically for in a bulb. Here you can see that a common electrical connection where the supply is basically that high voltage and low current, normally the voltage around 240 volt and the low current may be 5 amps like that. But when you try to use this electric current in the welding purposes, we use in different way. Here the current requirement is very high and the voltage requirement is the low, maybe standard or typical say 20 volt or 24 volt is required, but current may be depending upon the process, arc welding processes, or depending on the size of the workpiece, it can varies from 100 amps to say 200 amps, like that. So, that way the common electrical circuit is different from the what we use in kind of welding purpose. But point is that voltage, current, that actually decides the power of the arc, but polarity also is another important factor. So, polarity means what way we can use the positive and negative cathode, and what we decide the cathode and anode, which one should be positive, which one should be negative. So, there are several ways to decide the polarity. One is the DC, that means DC minus, that means direct current electrode negative, DC plus direct current electrode positive, and we can use also alternating current depending upon the application of the application, or maybe depending upon the materials and their typical characteristic, how is typical characteristics of the molten pool, what it is interacted with the surrounding materials or surrounding atmosphere. So, here specifically the heat, that different type of polarity, that means whether it is DC EP direct current electrode positive, or DC EN direct current electrode negative, or it may be AC, depending upon the polarity, the amount of the heat is generated in the electrode or amount of the heat is generated to the workpiece. So, that depends on the in general the type of the polarity we can use for the in this welding purpose. So, that maybe it is not necessary for the different welding processes should follow the different type of the polarity, but for example, GTAW and GMAW, the gas tungsten arc welding process and gas metal arc welding. In these two processes, there that we have the choice of the using the DC EN or DC EP or AC polarity depending upon the application or depending application on the materials. So, I will come to that point later on, the what is the typical utilization of all this thing. But thing is that if electrode negative and the workpiece is positive, in general, in that case the kinetic amount of the energy of electrode is basically exposed more on the workpiece surface. So, in that case we can expect the more amount of the heat generated in the workpiece surface. So, if our objective is to melt the workpiece material more, in that case we should use the DC EN polarity, that means workpiece positive and electrode should be negative. In that polarity around 70% heat will be generated in the workpiece, but our objective is to melt the consumable electrode. For example, in case of gas metal arc welding process we use the consumable electrode. So, objective is to consume more electrode. So, more amount of the heat generated is more preferable on the electrode. So, in that case direct current electrode negative is more preferable in that sense. So, in this mode DC EP, that more amount of the heat will be generated on the electrode than the workpiece material, and also AC current. So, in certain material, typical material, for example, aluminum, this mainly low melting point material which is having high affinity to form the oxides. So, in that case the AC current is more preferable. So, in this case maybe in alternatingly the 50% amount of the heat is generated in general in the electrode and 50% in the workpiece. So, the AC current basically helps to cleaning the oxide layer, and then remaining 50% amount heat is generated on the surface. So, in that sense if cleaning action is required or maybe to remove the oxides layer, so AC current is more preferable in that sense. So, that generally observed in the application of the welding of aluminum. So, electrical circuit basically decides that the nature, amount of the generation of the heat. So, we can see the electricity flow from the power source and through the electrode. Basically, if we consider the circuit in such a way that through the power source the electricity flow, and then it comes through the electrode, we use the electrode, and it passes through across the arc, and then that flow through the base material and again back to the power source. In that way it actually creates the electrical circuit here. So, formally we can say the electrical energy is basically converted to the thermal energy in the arc welding process. So, arc created by the electric current, here the converted heat into because of the resistance of the electric flow. So, resistance of the electric flow that actually responsible for the creation of the heat, and the heat melts the metal to fuse it together. After that heat melts the metal and to fuse it together. So, that physics of the arc welding process. Then just we will try to cover here the basic concept of the which generally used in the arc welding processes. Next to that point, enthalpy of melting, basically energy required to melt the material, what we can estimate or what are the factors is responsible for the to estimate the melting of the enthalpy of melting. So, straightforward we can find out what is the amount of the energy required, that heat energy required to melt a given volume of the weld. We estimate in that way, we can separate out these two parts. The heat required to melt the solid and then latent heat of fusion, that actually to change the phase from liquid phase to from solid phase to liquid phase, some amount of the latent heat is required. So, in that way we can estimate that Q equal to that first component is basically the latent heat the heat capacity, or maybe in this case that is called the specific, based on the specific heat, that component can be the melting point temperature raised from the ambient temperature to the melting point temperature, and the total heat content to raise the or heat required to raise the ambient temperature up to the melting point temperature with the same phase, solid phase, that is the amount of the heat required. And then second part is the latent heat required to change the phase. So, that is why the total amount of the heat can be considered that is required to the volume required to melt a given volume of the material. So, once we estimate the amount of the heat, and typically we can find out the weld zone is like that. First is the fusion zone, that is a molten zone. Of course, molten zone not exactly the amount of the heat generated just to melt, but here the application of the heat sets, it goes up to the some superheat temperature as well also. So, we are neglecting basically the enthalpy of melting, we are neglecting that superheat that amount of the heat required to superheat the material. Now, apart from the fusion zone, it some part is affected it is a solid state, but that is defined as the heat affected zone. So, that zone is affected by the heat, and that can be identified simply by phase transition with this zone, and of all this happens over the in the solid state, that means without the less than the melting point temperature. So, that zone is the heat affected zone, and other part is the base metal, that is the unaffected base, it is not affected by the application of the heat in this way. So, this is the typical characteristic of a basically the zone of the different oil zones in a specific fusion welding process. Now, what are the different energy sources are generally used in case of welding processes? So, of course, the energy here is used to produce the bond in the form of the heat, first making the heat, application of the heat to melt the metals, and then cooling of the metals through solidification process. So, here we will try to what are the different categorization of the heat source maybe we used for the fusion welding processes. So, first is the electrical sources. Of course, we use the electrical energy either available in the form of the AC alternating current or in the form of the direct current sources. For example, the different welding processes, arc welding processes, resistance welding process, electro slag welding, all the different welding processes, we just use the source, we use the different electrical sources to create the thermal energy. Second is the another source of the energy for the welding is the chemical sources. So, here the chemical energy is stored within a cylinder, and in the different form we can use the chemical energy. For example, the oxy-fuel gas welding. So, oxy-fuel gas welding, we can use the fuel cylinder and to make the gas welding processes. Even for thermite welding processes, in this case also that we can use the chemical energy, and of course, we use some in this case we use the thermite as a mixture of oxides and other materials, and that creates some chemical reaction, and that reacts that exothermic reaction, and that creates some amount of the heat, and that heat can be utilized for the welding purposes. So, in these cases the chemical sources actually acts as a to produce the generated heat. Optical sources, we can categorize the optical sources in this way, that fused beam of the electron or laser which is actually operated according to the law of optics. So, in this case that it can achieve a high power density, it creates, it is possible to the high power density, that means a high concentrated heat can be possible as compared to the other welding processes. So, typical example is the laser beam welding processes and electrical beam welding processes. In these two cases, we can use the heat source from the optical sources. Then mechanical sources, the involve the some amount of the mechanical movement of the movement that actually produce the amount of the energy. For example, friction welding. If you friction welding, basically if you try to give the mechanical motion of the substrate material and the high rotational speed, then even if it is contact with the another material and that at the contact surface, there may be the generation of the heat due to the friction, and that friction happens due to the mechanical motion of the substrate material. So, in that way, that some mechanical source can be used to generate the amount of the heat. So, that is friction welding, ultrasonic welding and explosion welding. All these kind of welding processes, the mechanical source is the actually produce the amount of the heat. Solid state sources, we can separate category the solid state sources. In this case is the it is categorized by a lack of the motion in contrast to the mechanical source, which that is in that sense we are not using the any mechanical sources here, or maybe we do not use the mechanical motion as a source of the generated heat, but rather in this case maybe with the application of the concentrated load or maybe distributed load is applied, and that is responsible for the joining of the material. So, that is one example is the diffusion welding, and in this case maybe the source of the energy can be considered as a solid state source. Now, when you analyzing the different energy sources is required for the welding process, now we will look back to the what are the different physical properties of the material and which may be significant in very specific to the welding processes or to analyze the different welding processes. So, physical properties basically of the materials influence the applicability of the different various joining processes. So, that is why we need to know the different physical properties of the materials, and that actually decides or that actually relates to the applicability of the different welding processes. So, that is why it is necessary to analyze the different physical properties of the metals. First is that electrical resistivity. So, electrical, it is having the maximum effect in the resistance welding and significant role in other processes like gas metal arc welding processes or gas tungsten arc welding processes. So, that is why we should know the what is the electrical resistivity of the material to decide the applicability of the different welding processes in principle. Thermal conductivity. So, what way the materials can transport the heat, that depends on the thermal conductivity. So, for example, some materials is having very high thermal conductivity, for example, copper is having high thermal conductivity. So, sometimes it is very difficult to weld, in the sense the application of the heat immediately the conduct away the amount of the generated heat. So, concentration of the heat is is probably less in this case to melt the material. So, that is why it is necessary to know the thermal conductivity of the, it is a very significant parameter that decides the applicability of the different welding processes. So, in general pure metal is having good thermal conductivity, but if we try to if we add on the alloying elements, generally the thermal conductivity reduces. Next is the coefficient of expansion. The thermal expansion coefficients in welding of the materials also is equally important to analyze the distortion of the welded specimen, because the application of the thermal energy, or there may be the thermal strain will be produced, and the thermal strain is that amount of the strain is that depends on the distribution or expansion coefficient. So, or maybe if there are two different materials, there is a huge difference in the thermal expansion coefficients, probably in this case there is a difficulty of joining these two materials, or maybe the two materials having the similar range of the two dissimilar materials having the similar range of the expansion coefficient. So, probably in that case the joining will be little bit ease. So, that thermal expansion coefficient is another important parameter, and that directly linked to the distortion analysis of a welded joint. Specific heat, we understand the measure or amount of the heat content, or it can absorb amount, or it can store the heat. That amount is basically decided by the specific heat of a specific material. Ionization potential. So, different materials, the ease of arc initiation, basically when you try to do the arc welding processes, how ease we can create the arc and what way easily we can maintain, or the arc can be stable, that actually relates to the ionization potential of a specific material. So, to get a initiation of the arc easily, and we can stability as minimum as possible, ionization potential of the material is required in this sense. Metal oxides, of course, oxidation rate is another critical problem in the welding process. So, different materials, the oxidation rate are different, and the refractory stability, when this between the metal oxides, the stability of the metal oxides during the welding is basically affects the transfer of the heat from the any source, or it also depends on the different alloying elements of the parent metal. So, that is why it is very important to know the oxidation rate of a specific material, or the nature of the metal oxides, and when you try to weld when you try to select the any welding process for a specific material, it is necessary to analyze the metal formation of the metallic oxide. Just to give an example, that aluminum oxide, aluminum is having high rate of oxidation and easily form the aluminum oxide. So, that is why when you try to choose the welding process, we generally use the alternating current, AC current, such that it creates or it removes the oxide layer in the half of the cycle, and remaining time of the cycle time it is the simply heat the material. So, in that sense the analysis of the metallic oxides is required.